All right, let's jump right into it. We're going to talk about two words we use all the time, probably without even thinking about it: speed and velocity. I mean, we use them like they're the exact same thing, right? But what if I told you there's just one little word that makes them totally different? And once you get it, you'll see everything that moves in a whole new way.
I mean, let's be honest with ourselves. When you're driving and you say your speed is, I don't know, 60 miles an hour, do you ever stop and think, should I be saying velocity instead? No way. For most of us, myself included, those two words are basically twins. We swap them out all the time.
And you know what? For just getting through the day, that's perfectly fine. But if you want to get a little more precise, especially in the world of physics, there's this tiny but super important catch. It's the one thing that splits these two ideas wide open. And you don't have to take my word for it. Our source material just lays it out there, plain and simple. Speed and velocity are not both the same. It's like, boom, right there, a direct challenge to how we usually talk. Okay, so let's actually break this down. What's the real difference here? We're going to start with the one we all know and love, the easy one. First up, our old buddy, speed. This is the one that just makes sense, right? It's the number you see on your car's speedometer. It's how fast you're cranking on the treadmill. It's simple. So what is it really? Speed is just how fast something's moving. That is literally it. The fancy term for this is a scalar quantity. And all that means is it's just a number. That's it. 60 miles per hour, 10 kilometers a second. It only tells you the how fast part, the magnitude, but nothing else. Okay, so if speed is just a number, what makes velocity so special? Well, this is where it gets cool. Velocity takes everything we just said about speed, and then it adds one single game-changing secret ingredient. And look at this. This is what I love. The difference is so simple, it's almost funny. They both care about how fast. You can see it right there. But velocity throws in that one extra little thing. In which direction? That's it. That is the whole shebang. The key to this entire concept is that one little phrase. So, to put it all together, velocity is the speed of something, but in a very specific direction. This makes it what they call a vector quantity, which just means it needs two pieces of info to be complete: the magnitude, how fast, and the direction, which way. It's not enough to say you're going 60 miles an hour. For velocity, you have to say you're going 60 miles an hour north, or east, or whatever. You need both pieces of the puzzle. All right, so speed is a number. Velocity is a number plus direction. They're different. We get it. But, and this is where it gets really interesting, there's one special situation where that big, important difference between them just disappears. And that brings up a really good question, right? If they're built differently, how on earth can they ever be the same? When can a number plus a direction equal just a number? Well, again, the source material gives us this awesome, simple answer. It all comes down to moving in a straight line. It says, but in straight line motion, they are same. When something is just chugging along in one single direction, that's when speed and velocity become one and the same. And think about why that is. It makes perfect sense. If you're moving in a perfectly straight line, what's happening to your direction? Well, nothing. It's constant. It's not changing at all. So that whole which way part of velocity is just locked in. It's a given. So the only thing left that can change is how fast, which, hey, what's that? That's the definition of speed. So let's put this all together. How can you remember this from now on without having to think too hard? I've got a super simple two-step mental checklist for you. Okay, from this moment forward, whenever you see something moving, just ask yourself these two questions. First, how fast? Boom, the answer is your speed. Got it? Then ask the second question, which way? If you can answer that too, you've now got the velocity. It's that easy. And here's the perfect example to make this crystal clear. Picture a race car on a circular track. That car's speedometer could be glued at 150 miles per hour, right? So its speed is constant. But is it going in a straight line? No way. It's constantly turning. Its direction is changing every single second. So its velocity is also changing every single second. Now take that same car and put it on a dead straight highway. Lock the cruise control at 70. Now what? Its speed is constant and its direction is constant. So in that one specific case, its velocity is constant too. See the difference? So I'm going to leave you with a little thought experiment. The next time you're in a car or even just walking down the street, think about your journey. With every single turn you make, every curve in the road, every time you stop at a light and start again, ask yourself,
When, during that entire trip, was my velocity truly constant? I'm willing to bet you'll find it's almost never. And that right there is the power of that one little word that separates speed from velocity.